Where are you right now? In bed, lights off, the world outside gone still, or somewhere else? A couch, a chair, a corner of the night you have claimed as your own. What time is it? Whatever the answer, I need you to hold it for a moment. Notice the room. Notice the quiet. Notice that outside these walls the sky is full of stars, and among those stars, hundreds of billions of them, in this galaxy alone, there's not a single confirmed signal from another mind. Not one. In a universe this vast, this old, this full of the right ingredients for life, the silence is total. And tonight, we're going to sit with that silence, follow it where it leads, and arrive at the answers that serious scientists have proposed. Some of them are beautiful, some are strange, and some, the ones we will spend the most time with, are so deeply unsettling that once you understand them, the quiet of the night around you will feel different. Not worse, not necessarily, but heavier, more honest, more true. Close your eyes if you want. Let your body settle. We're going somewhere real tonight, into the most important unanswered question in science, and the answer, whatever it turns out to be, may already be written in the silence above you. Let us begin. The Fermi Paradox is not complicated to state. It is only complicated to live with once you've understood it properly. Here is the statement in its simplest possible form. The universe is very large and very old, and full of the conditions necessary for life. Given these facts, there should be other intelligent civilizations out there, many of them, perhaps millions, and at least some of them should be detectable from Earth, whether through their signals, their engineering, their expansion, or simply the accumulated evidence of their existence. Yet when we look, when we listen, when we scan, when we search, we find nothing. No signals, no megastructures, no visitors, past or present, no evidence whatsoever that any other intelligence has ever existed in the observable universe beyond our own. The paradox is the gap between what the math predicts and what observation delivers. The math says the galaxy should be full. Observation says it is empty. These two statements cannot both be true, and yet they appear to be. This is the Fermi Paradox, named for Enrico Fermi, the brilliant Italian physicist who asked the question over lunch in Los Alamos in 1950. The story goes that Fermi and his colleagues were discussing the possibility of extraterrestrial intelligence, laughing about a cartoon of flying saucers, when Fermi set down his fork and asked, with the directness of a man who thought about things clearly, "But where is everybody?" His colleagues laughed. The question was obvious. But the more carefully they thought about it, the less obvious the answer became. 75 years later, the question is still open. We have better instruments. We have more data. We have more computing power. We have more theoretical frameworks, more proposed solutions, more careful analyses, and the silence is still total. Fermi's question, asked over lunch, has become the deepest unanswered question in science. Where is everybody? The universe is 13.8 billion years old. It contains 2 trillion galaxies. Each galaxy contains hundreds of billions of stars. Many of those stars have planets. Many of those planets are old enough to have produced intelligent life long before Earth even formed. The question is not whether other life should exist. By the numbers, it should. The question is why we cannot find it, why the sky is silent, why the frequencies are empty, why nothing out there has ever, in all the time we have been listening, sent us any signal that we could not explain as natural. That question is the Fermi Paradox, and it has no comfortable answer. In 1961, in a small conference room in Greenbank, West Virginia, a young astronomer named Frank Drake picked up a piece of chalk and wrote an equation on a blackboard. It was not a long equation. It had only 7 terms. And the question it was attempting to answer was one of the most profound in the history of human thought. how many intelligent civilizations capable of interstellar communication exist in the Milky Way right now? The Drake equation, as it became known, tried to calculate this by multiplying together a series of probabilities. How many stars form each year? Of those, how many have planets? Of planetary systems, how many contain habitable worlds? On habitable worlds, how often does life arise? How often does life become intelligent? How often does intelligence develop communication technology? And, crucially, how long does a communicating civilization survive before going silent? Each factor carries uncertainty. Scientists argue about the numbers, but even under conservative assumptions, even giving each factor the most modest plausible value, the equation produces a result that is not zero. It produces a number that says civilization should exist, should have existed, should have left traces. Even the most pessimistic reasonable estimates produce at least a handful of civilizations in the Milky Way alone across its history. And if the estimates are optimistic, if life arises frequently, if intelligence is a common outcome, if civilizations tend to be long-lived, the number explodes into the millions. Carl Sagan thought the number could be 1 million or more. Some researchers using modern data on planetary abundance have pushed their estimates higher. The specific number is not the point. The point is that no serious scientific analysis of the Drake equation produces zero. Something should be there. Something should have been detectable. And if even one civilization in the galaxy achieved the ability to colonize other star systems and began doing so at even a small fraction of the speed of light, it would have colonized the entire galaxy within 100 million years. The galaxy is 10 billion years old. 100 million years is 1% of that. If colonizing civilizations arise even rarely, the galaxy should be full of them and full of evidence of them by now. It is not. The math says it should be. Reality says it is not. The gap between those two statements is the Fermi Paradox, and closing that gap requires an explanation. Every explanation that has been seriously proposed is, in its own way, disturbing. The search began officially in April 1960, when Frank Drake pointed the Greenbank radio telescope at two nearby sun-like stars, Tau Ceti and Epsilon Eridani, and listened. He called the project Ozma, after the ruler of an imaginary far-off land. The name was apt. He was listening for something real in a direction that might well be fantasy. He heard nothing. But the attempt mattered. For the first time in history, a human being had deliberately and systematically searched the electromagnetic spectrum for evidence of another mind. The tradition grew. SETI, the search for extraterrestrial intelligence, became a field, an institution, a decades-long effort to listen carefully and persistently to a sky that had never given us any reason to expect silence. Millions of frequencies, billions of star systems surveyed across the decades, teams of researchers, generations of telescopes, enormous databases of electromagnetic signals analysed by algorithms and by human eyes, looking for the one pattern that could not have been produced by nature, a structured signal arising from intelligence. And in all of that listening, in all of that searching, across all of those years, one thing has been found that made scientists stop and pay attention. On August 15th, 1977, a volunteer researcher at Ohio State University named Jerry Eman was reviewing a printout of radio telescope data when he encountered a signal so unusual he circled it in red pen and wrote a single word in the margin: "Wow." The signal was strong. It was narrowband, meaning it occupied a precise and narrow slice of the radio spectrum in a way that natural sources do not. It lasted the full 72 seconds that the telescope's scanning beam would capture a fixed source. It had the characteristics that theorists had predicted an artificial extraterrestrial signal might have. It came from the direction of the constellation Sagittarius. It has never been explained. It has never been detected again. Decades of follow-up observations of the same region of sky have found nothing. The WOW signal sits in the record as the most tantalizing anomaly in the history of SETI, significant enough to have a name, unexplained enough to remain open, isolated enough to prove nothing. 75 years of listening. One anomaly. No confirmed signal. No pattern that required an intelligence to produce it. Nothing in the sky except what physics and chemistry and the indifferent processes of the universe produce without any help from a mind. The silence, built up across 7 decades of increasingly sensitive search, is not casual. It is not the silence of a question not yet asked. It is the silence of a question asked loudly, carefully, repeatedly, for 3 generations, and answered by nothing at all. There is a concept in physics called the conservation of information, and it is one of the strangest, most debated, most consequential ideas in modern theoretical physics. It is also the place where the question of immortality stops being metaphorical and starts being mathematically serious. The idea begins with quantum mechanics. At the quantum level, the state of any physical system can be described by what physicists call a wave function, a mathematical object that encodes everything there is to know about that system. Every particle, every atom, every arrangement of matter and energy has a wave function that describes it completely. The conservation of information says this: that wave function never truly disappears. It can evolve. It can become extraordinarily complex, spread across many particles, entangled with the environment in ways that make it practically impossible to read. But it cannot be destroyed. The information encoded in the quantum state of any system is, in principle, permanent. This was the center of one of the most famous debates in modern physics, the so-called black hole information paradox. Stephen Hawking originally proposed that black holes could destroy information, swallowing matter and eventually evaporating through Hawking radiation without preserving any record of what they consumed. If true, this would violate the conservation of information, and most physicists found this deeply troubling. Decades of theoretical work, culminating in what is sometimes called the black hole wars, has led most physicists to believe that Hawking was wrong about this, that even black holes preserve information, that the quantum state of everything that falls in is somehow encoded in the radiation that eventually comes out, scrambled beyond any practical recovery, but preserved. Nothing is lost, not even in the most extreme physical process the universe produces. What does this mean for you? Lying here in the dark, breathing slowly, on the edge of sleep. It means that the quantum state that describes you, every particle in your body, every relationship between those particles, every pattern of energy that constitutes what you physically are, is information. And if the conservation of information holds, as most physicists now believe it does, that information is not destroyed when the arrangement changes. It is scrambled. It is dispersed across the universe in a form that cannot practically be recovered. But it is there, encoded in the fabric of physical reality, in the correlations between particles that will never entirely lose the memory of what they once were part of. You leave a mark on the universe that the universe keeps, always. The question of what you are precisely is one that physics and philosophy have never fully agreed on, and the disagreement is more interesting than any settled answer would be. On one view, you are the pattern, the arrangement, the specific configuration of atoms and energy that has a particular history, makes particular choices, experiences the world in a particular way. The atoms are just the medium, the way that ink is the medium for a poem. The poem is not the ink. It is the pattern the ink makes. Change the ink, the poem remains. Destroy the pattern, and the poem is gone, even if every molecule of ink still exists somewhere. On this view, when the arrangement changes, you are gone, even though your atoms persist. The atoms continue, but you do not. Immortality of matter, not immortality of self. This is a reasonable view. Many physicists hold it implicitly. But there is another view, and it is harder to dismiss than it appears. On this view, the distinction between pattern and substance is not as clean as it seems, because the pattern is not separate from the energy. The pattern is a property of the energy, a way the energy is organized, and if the energy persists, and the information encoded in that energy persists, then something of the pattern persists too. Not in a recoverable form, not in a form you would recognize as the same person, but as a set of constraints, relationships, correlations that the universe carries forward. Think of it this way. When you speak, you create sound waves. Those waves travel outward, interact with everything they meet, are absorbed and reflected and dispersed. Within seconds, the specific sound wave is gone, indistinguishable from the background. But the energy of those waves has been added to the thermal motion of the air, the walls, the objects in the room. The room is, in a completely unmeasurable but physically real sense, slightly different because you spoke. You change the universe, and the universe keeps the change. Every moment of your existence has altered the state of the physical world in ways that propagate forward through time, not memorably, not recognizably, but permanently. You're woven into the universe in ways that cannot be unwoven. This is not poetry designed to comfort you, though you're welcome to be comforted by it. This is the structure of a physical system in which causality is real, in which every event has effects, and in which those effects do not disappear. The universe remembers, even when we cannot. Comfort you. By it. There is a thought experiment that physicists and philosophers have used for centuries to probe the nature of identity, and it becomes newly strange when you place it inside the framework we've been building tonight, the ship of Theseus. You know the story, perhaps. A ship is preserved in a harbour as a monument. Over time, its planks rot and are replaced, one by one. After enough time, every single plank of the original ship has been replaced. Is it still the same ship? Now extend it further. Someone collects all the original planks, repairs them, assembles them back into a ship. Which one is the ship of Theseus? This is not an idle puzzle. It is a direct question about whether identity lives in material or in pattern, in substance or in continuity, in what something is made of or in what it is organized to do. And now apply it to you. The atoms of your body are not the same atoms you had 7 years ago. Almost every cell in your body has been replaced, sometimes several times over. The matter that constituted you as a child is scattered across the world now, in the soil, in the water, in other organisms, yet you have an unbroken sense of being the same person. You have memories, habits, a persistent sense of self that bridges all those replacements. So which is you? The atoms or the pattern? If it's the pattern, then the pattern has demonstrated remarkable resilience. It has survived the complete replacement of its physical substrate multiple times. It persists not because the matter is the same, but because the organization is maintained. The pattern maintains itself. And if the pattern can maintain itself through complete material replacement while the organism is alive, then the question of what happens when it doesn't is at least more interesting than we usually allow. What does it mean for a pattern to end? If the energy that was carrying it doesn't end, where does the organization go? These are not questions physics has answered. They are questions physics has made more precise and more strange by understanding how deep the conservation laws go, how thoroughly the universe preserves information, how completely causality ensures that nothing simply vanishes. You are a pattern that has already survived complete material replacement several times. The universe has a long and unbroken record of not destroying things. Put those two facts side by side, in the dark, and let them sit there together without needing to resolve into anything. There is no resolution required tonight, only attention. Let's talk about what happens when a star dies, because it is the closest analogy the universe has to what we call death, and understanding it changes the emotional weight of that word considerably. A star like our Sun exists in a state of dynamic balance. The outward pressure of nuclear fusion in its core, the constant explosion of hydrogen into helium at temperatures of 15 million degrees, precisely counterbalances the inward pull of gravity. This balance is maintained for billions of years, as long as the fuel holds. When the fuel runs low, the balance breaks. The core contracts. The outer layers expand enormously. The star becomes a red giant, swelling to many times its original size, its surface cooling as it spreads. Eventually, for a star our size, the outer layers are shed entirely, forming a glowing shell of gas called a planetary nebula, one of the most beautiful objects in the universe. What remains is the core, compressed to a sphere roughly the size of Earth, but with the mass of a star, a white dwarf, incredibly dense, fading slowly over billions of years as it radiates away its remaining heat. Eventually, theoretically, it becomes a black dwarf, a cold, dark remnant indistinguishable from the background. But notice what has happened. Every atom that was in the star is still somewhere. The planetary nebula drifts through space, enriching the surrounding gas with carbon, nitrogen, oxygen, the products of the star's nuclear history. That gas will eventually be incorporated into new molecular clouds, new stars, new planetary systems. The heavy elements the star spent billions of years making are now available to the universe for the first time. Seeds of chemistry, seeds of planets, seeds of life. The star did not end. The star transformed. What was organized energy in a particular form became organized energy in other forms, dispersed across space, contributing to the next generation of complexity. This is the pattern the universe follows. Not annihilation, transformation, not ending. Continuation in a different key, and a human body, when the arrangement that organizes it stops being maintained, follows the same pattern. The molecules are broken down, the atoms disperse, they enter the cycling systems of the biosphere, the soil chemistry, the water cycle, the food web. They become other things, and those things become other things, in an unbroken chain of rearrangement that the universe has been running since it began. The star died and became the material for a world where someone is lying in the dark, thinking about stars. That chain has no break in it anywhere. Began. For a world where someone is lying in the dark, thinking about lying in the dark. The physicists who refuse to talk about this, the ones mentioned in the title of tonight's journey, are not being dishonest. They are being careful. The careful thing, in physics, is to stay close to what the mathematics says and to be extremely cautious about what you claim those mathematics mean for questions like consciousness, identity, or experience. These are questions that have a long history of being answered too quickly and too confidently, in directions that turned out to be wrong. So they talk about conservation of energy without connecting it to immortality. They talk about conservation of information without connecting it to the persistence of self. They describe the block universe without dwelling on what it means to be a permanent object in four-dimensional space-time. They discuss quantum branching without following the thread of what it implies for the continuity of experience. This caution is reasonable. It is probably the right professional practice. But in the quiet of a late night, in the particular kind of attention that the hours before sleep produce, caution is not what is needed. What is needed is honesty about what the physics actually implies, without the professional filter, without the anxiety about being misunderstood, and what the physics implies taken together is genuinely extraordinary. Matter persists, energy persists, information persists, in principle, in the structure of quantum correlations that the universe carries forward. Time is a dimension, and every event that occurs is a permanent fixture of the space-time structure. The cycles of matter have no end in sight. The branching of quantum possibility expands continuously into futures that none of us can map. And in the middle of all of this, you exist. Not as a temporary irrelevance, not as an accident, as a specific, precise, unrepeatable configuration of matter and energy and information that the universe has assembled from material it has been carrying since the Big Bang. You are not something the universe is tolerating for a short while before discarding you. You are something the universe is doing, a process it is running, a pattern it is maintaining, for as long as the conditions for maintaining it hold, and then transforming, as it transforms everything, into other forms that will carry the traces of what you were in ways that cannot be fully erased. The physicists are careful, but the physics, allowed to speak for itself, in the dark, without the professional caution, says something close to what the oldest human intuitions have always said. You matter, and matter is not destroyed. There is something that happens to the quality of thinking late at night that is worth naming before we go further. During the day, the mind tends to stay close to the practical. It moves between tasks, between problems that have solutions, between questions that have answers. It is a tool being used, and tools stay sharp by being applied to specific work. At night, especially the deep night, especially the night before sleep, the mind loosens its grip on the practical. The horizon of what feels like an appropriate question expands. Things that seem too large to think about during the day, too abstract, too far from anything actionable, begin to feel not only thinkable, but necessary, as if the night is the only time large enough to hold them. This is why we are here, you and I, in this particular hour. The question of what you are, fundamentally, what persists, what the universe keeps of you, is not a question that the daytime mind usually allows itself to sit with. It is too large. It has no practical consequence in the immediate sense. It doesn't help with the thing due tomorrow, or the conversation you need to have, or the choice waiting for a decision. But it is possibly the most important question there is, and the night allows it. So let's use the permission the night is giving us and go somewhere we don't usually go. What if the physics is right? What if the conservation laws, the block universe, the conservation of information, the cycling of matter, the quantum branching? What if all of this adds up to something that deserves the word immortal? Not immortal in the sense of unchanging, not immortal in the sense of continuing to experience as the person you are now, but immortal in the sense that nothing about you, nothing that has been part of you, disappears, in the sense that the universe carries you forward in every form it can for as long as the universe continues. What would it feel like to take that seriously, not as a belief system, not as a comfort story, as a physical fact being considered with the same seriousness as any other physical fact? I think it would feel something like what you might be feeling right now, expansive, a little vertiginous, quietly enormous. Considered with the same seriousness as any other physical fact. I think it would feel something right now, seriousness as any other right now. The night is deep now, the ideas have been large, and the mind has been generous in holding them, and now it is appropriate for the holding to become easier, gentler, less effortful. This is not the end of the thinking. It is a change in how the thinking is held. Think of the difference between gripping something and cradling it. Both are ways of holding. But gripping requires constant tension, constant attention, constant correction. Cradling uses the shape of the hand, the natural weight of the object, the relationship between them. Cradling is more sustainable. It is the way you hold something you intend to keep for a long time. The ideas from the first part of tonight, the conservation laws, the block universe, the cycling of matter, the conservation of information, the quantum branching, those are worth cradling rather than gripping. They are too large to hold tightly without exhausting the hand. But they settle comfortably into a cradled attention, and from there they continue to do their work quietly without requiring effort. So let the grip ease a little now. The matter persists. You know this. The energy persists. You know this. The block universe contains every moment of your life as a permanent fixture. You know this. The universe has never once destroyed anything in 14 billion years. You know this. And whatever you are, beyond the physical account, physics has not said it ends. It has said, carefully and precisely, that the question remains open, which is more room than is usually acknowledged. You're lying somewhere in the world, in the dark, with this inside you now, alongside everything else that is inside you at the end of a day. The body is heavy, the breath is slow, the day is behind you in a way it wasn't a few hours ago, and underneath all the specific ideas, what remains is something simpler, a quality of attention, a sense of scale, a feeling of being something larger than usual, connected to something longer than a single life, made of something older than this planet. That feeling is not an error. It is the appropriate response to physics taken seriously. It is the emotion that conservation of energy produces when you let it. Let it. There is a quality to starlight that becomes important once you know what it is. When you look at a star, you're not seeing the star. You're seeing light that left the star years or centuries or millennia ago, and has been travelling through the vacuum of space since then, and has just arrived at your eyes. You're seeing the past. The star you're looking at may not exist anymore. It may have changed beyond recognition. The light arriving now is the last transmission of something that may already be gone. And yet the light is real, arriving now, carrying real information about what was. There is something in this that rhymes with what we have been talking about. The pattern of a life is like starlight. By the time others perceive it, it has already travelled a distance. What they receive is a record, not the source, but the record is real. The light genuinely carries information about the star that emitted it. The image is not false, it is just prior. What does it mean to be perceived by the universe? Not by other people, though that is also real. By the physical universe, which keeps every record, which carries every causal trace of every event forward into the future. In the technical language of physics, every event leaves what is called a causal shadow, a set of future states of the universe that are different because the event occurred. Your existence casts a causal shadow across all of space-time that comes after you. Not a visible shadow, not a shadow that can be traced or read, but a shadow in the sense that the universe that follows your life is different from the universe that would have followed a universe that didn't contain you. You have already changed the world in ways that will propagate forward indefinitely. Not the dramatic changes, necessarily. Not the famous moments, if there are any. The ordinary ones, the words spoken, the weight placed on the floor, the breath released, the heat exchanged with the air, all of it, every physical interaction, however small, has altered the state of the world in ways that continue because causality is real and it does not stop. You are already immortal in the sense that the universe is already carrying you forward in its physical record, in the causal shadow you have cast, in the light you have emitted into the world that is still travelling outward. Whether there is someone inside that light who can feel it travelling is the question that remains open, but the light is real, and light, once emitted, does not stop. In the causal shadow, in the light you have inside that light who can feel it, once emitted, stop. In the light you have stop. The breath comes and goes, each one the same as the last, and yet each one new. The air that fills the lungs was somewhere else a moment ago. The air that leaves was inside you, warm, carrying the traces of what happened in there. It goes back into the world, changed slightly, becoming something else. Each breath a small version of everything we have been talking about. In, out, in, out. Nothing created, nothing destroyed, everything transformed, continuously, at the rate of one breath every few seconds, at the rate of one heartbeat every second, at the rate of millions of chemical reactions per moment. In every cell of a body that is both you and the universe doing something with its matter. The body doesn't need your direction to do this. It does it on its own, in sleep, without consciousness, without intention, following the rules that are built into it, that are built into the matter it is made of. In sleep, the body continues. The chemistry continues. The atoms continue their transactions, their bonds made and broken, their electrons shared and returned. The matter that is you keeps being organized, keeps maintaining the pattern, keeps running the cycles that have been running since before any organism existed. And the mind, in sleep, continues in its own way, processing, consolidating, finding patterns in the day that the waking mind missed, building the connections that will be there, mysteriously, when morning comes, doing the maintenance that the daytime running couldn't stop for. Sleep is not absence. It is a different mode of presence, a mode the universe runs more smoothly, more sustainably than the waking one, a mode that has been running in living things for hundreds of millions of years, longer than many entire categories of complex life have existed. You're about to become the ancient thing that living creatures do at night. You're about to join the long unbroken chain of organisms that have closed their eyes in the dark and trusted the universe to maintain the pattern until morning. And the universe has a very good track record on this. It has maintained the pattern of living things through hundreds of millions of years of nights, through ice ages and mass extinctions and every catastrophe that has ever reshaped life on this planet. It will maintain yours through this one. The breath, in, out, the body heavier, the mind releasing, the universe holding, as it has always held, everything it has ever made. There is a word for what the body is doing right now. In the language of thermodynamics, it's called a dissipative structure. Ilya Prigogine, who won the Nobel Prize in Chemistry in 1977, showed that complex ordered structures can maintain themselves and even grow more complex by dissipating energy, by taking in energy from the environment, using it to maintain their organization, and releasing it in a lower quality form. A flame is a dissipative structure. It takes in fuel and oxygen, maintains its pattern of burning, and releases heat and light and carbon dioxide. The flame is not made of fixed material. Different molecules are burning every moment. The flame is a pattern maintained by the flow of energy through it. You are a dissipative structure, a more complex one than a flame, but the same principle. You take in food and oxygen, use the energy to maintain the extraordinarily complex organization that is a living body, and release heat and carbon dioxide and other metabolic products. The specific atoms in you are constantly changing. The pattern is maintained by the flow. This is a beautiful and important thing to know about yourself. You're not a fixed object. You're a process. A pattern maintained in flowing matter, the way a whirlpool is a pattern maintained in flowing water. The specific water molecules that make up the whirlpool change constantly, but the whirlpool persists, as long as the conditions that maintain it hold. And when the conditions change, the whirlpool doesn't disappear. The water continues, now without the vortex, carrying the energy that the vortex had organized, dispersing it into the broader flow. You're a whirlpool, a spectacularly complex one, made of matter that has been flowing through the universe for 13 billion years, organized for a time into a pattern that experiences itself, that wonders about its own nature, that lies in the dark asking questions about whether it is immortal. And the answer, in the thermodynamic sense, is the same as the answer for the whirlpool. The pattern will eventually dissolve into the broader flow. The matter will continue in other patterns. Is the same as the answer for the whirlpool. The into the broader flow. Is the same as the answer for the whirlpool. The for the whirlpool.